Alright, today should be a pretty easy day. We're reviewing linear equations, which is all stuff that we learned last year in algebra. So hopefully this seems pretty familiar to you. In our warm-up, we're going to write some equations of lines. We're going to start with the line including these 2 points. We're going to write it in point-slope form. Then we're going to write an equation of the line perpendicular to that line, going through this point in slope-intercept form. And finally, we're going to write the equation of the line parallel to the first line, going through this point in standard form. So I would like you to, if you haven't done this, pause the video and try to do these 3. Make sure you remember that stuff, and then I'll go over the answers to that. But do try it on your own. I want to make sure that this stuff is still with you from what we did last year in algebra. Okay, so the line including 3, 8, and -2, -7 in point slope form. Well, we have points. What we need is a slope. So to find the slope, we use our 2 points and we find the change in y. So I could do that as 8 minus -7 over the change in x. I could do that as 3 minus -2. So I have 15 over 5. My slope is 3. You could also have done -7 minus 8, -2 minus 3. The order doesn't matter. I can call this x1, y1, or this x1, y1. Any 2 points form the same line. So all that happens is I'd have -15 over -5. I still get 3 for the slope. So now that I have a slope and I have some points, I could write an equation. So to write an equation in point-slope form, we do y minus the y-coordinate of the point we're looking at, so 8, equals our slope, 3, times x minus the x-coordinate that's paired with that y-coordinate, x minus 3. So you could also have written, using the other point, y plus 7, because we're doing minus -7, equals 3 times x plus 2, because that's minus -2. Both of these are valid point-slope equations, which is why it says an equation. We could use any point on that line to write this form of the equation. So there's really infinitely many different versions of it, depending on which x and y pair we plug in. Whereas number 2 says write the equation. So there's only one correct slope-intercept equation for any given line. So if we write the equation of the line perpendicular to that line, so our slope here was 3, so the thing we need to be aware of is that our new slope, m2, is going to be the opposite reciprocal of this slope. So our new slope is -1/3. And we want to pass through the point -12, -4. And since we're writing this in slope-intercept form, we can start off either with point slope like we did here and rearrange it, or we can solve for our missing y-intercept by substitution. To do that, we plug in this x, this y, and this slope to slope-intercept form. So we would get -4 equals m times x, that's a -12, plus b. And that allows us to solve for the missing y-intercept. So if I multiply that, this is +4, it looks like. 12 over 3, +4. Subtract it to the other side, we get b equals -8. So our equation, our second equation, would be y equals, and then we would have -1/3 x minus 8. So this is our first equation, this is our second equation. And the final one, we're going to write the equation of the line parallel to the first line passing through this point in standard form. And again, this is the equation. There should only be one standard form equation for any given line. So to be parallel to the first line, that means our third slope is the same as the first one, so that's 3 again. To write in standard form, it's generally easiest to start with either point slope or slope intercept and then rearrange it into standard form. So I'll start with point slope form and do y plus 3 equals 3 times x minus 6. Then I can rearrange this to get into standard form by doing y plus 3 equals 3x minus 18. And we had a couple of rules for standard form. One rule is x and y have to be on one side and the constants have to be on the other side. So if I move this over here, I'll have -3x plus y And if I move this 3 over here by subtraction, we'll have negative 21 over here. So our second rule for standard form was that, well, actually that wasn't even one of the rules, that's just convention. So the two rules are a, b, and c, the coefficients of x, y, and c, or the constant, have to all be integers, which they are. 3 is an integer, 1 is an integer, and 21 is an integer. The second rule is that a, the one in front of x, cannot be negative. So we're going to need to switch all of our signs and get 3x minus y equals positive 21. So this is our standard form equation. And there's kind of one more rule we don't emphasize in algebra or maybe anywhere, which is there's only one standard form equation. So if I wrote the equation 6x minus 2y equals 42, that would also define the same line as this one, but it is not valid because there's a GCF, a greatest common factor of a, b, and c. So we would need to simplify this by dividing out the 2 and bring it back to be 3x minus y equals 21. This is the only standard form equation that's valid for this line. So hopefully that jogged some memories about how these different forms work, how the slope formula works. We're going to talk about a couple of additional things to add. So to review forms of linear equations, we have 3. So we have slope-intercept is like the first one that you learned about. So slope-intercept takes the form y equals mx plus b, where m is the slope and b is the y-intercept, where the graph crosses, or where the line crosses the y-axis. So if we're drawing our graph, the y-intercept is right there. Okay, so that's slope-intercept. The next version was point-slope. Point-slope form looks like y minus y1 equals the slope m times x minus x1, where m is again the slope and x1, y1 is a point on the line. So we can plug in any point that we know about along with the slope, and that will do it for us. The last form was standard. Standard form looks like ax plus by equals c. And this one had some rules. So a, b, and c are all integers, so no decimals or fractions. They all have to be either positive or negative whole numbers. A is always positive, so if a comes out to be negative, we have to switch all 3 signs so that a is positive. And then the third rule, like I said, we didn't really talk about, is no GCF present in our final answer. So basically simplified. All right, so those are our 3 forms. Along with those, to do these 2, we often need the slope formula. So we calculate slope by basically the same formula as what's shown for point slope form, just rearranged a little bit. So slope is y2 minus y1 over x2 minus x1. So y2 and y1 come from 2 points on the line, and then x2 and x1 come from the same 2 points in the same order. So we did an example in the warm-up, but just to do another one, if we had 1, 4 and 3, negative 7, we could label this x1, y1, and this x2, y2. So we'd calculate the slope as negative 7 minus 4 divided by 3 minus 1, and we would get negative 11 halves. All right, so those are all things hopefully that are review from algebra and from the algebra star chart. Next we have slope formula we just looked at. We have the ideas of parallel and perpendicular, and then we have 2 kind of new things, parallel postulate and perpendicular postulate. So slope formula we talked about on the last slide, parallel and perpendicular. So parallel is 2 coplanar lines that never meet. So to get that, we need m1 equals m2. So we have the same slope between the 2 lines, but we also need b1 is not equal to b2. That means that these are two distinct lines. So there's two ways of going about it. We could say b1 is not b2, or we could say two distinct lines with different slope. So the distinct lines takes care of saying that they're not coinciding, so they don't have the same y-intercept. Remember, coinciding is our vocabulary word for when two lines have the same slope and the same y-intercept, and they draw the exact same line, more or less. Okay, so that's parallel. Perpendicular is another relationship about slope. And both of these rely on being coplanar. So these are dealing with two distinct lines within a plane. And perpendicular, our new slope is going to be -1 divided by the original slope. So in words, we say this is the opposite reciprocal. So if I have a slope of 3, my opposite reciprocal, I flip it upside down. So this was 3/1. It becomes 1/3. That's the reciprocal part. And then the opposite part is I make it negative. So 3 and -1/3 are opposite reciprocals. 7/2 and -2/7 are opposite reciprocals. And one relationship you get by this is if you multiply the slopes together, you're always going to get -1. So the product of the two slopes is -1 because the reciprocal cancels out and just leaves us with 1, and we always have 1 negative. So unless you have a vertical and horizontal line, then you can't really multiply because you have an undefined slope. So that's one thing this doesn't cover is if you have m1 is 0, then m2 is undefined, and vice versa. So that would be if you have a vertical line with an undefined slope and a horizontal line with a slope of 0, those will always be perpendicular. So this relationship about opposite reciprocals is kind of going, and same slope here are both reliant on not vertical lines, because vertical lines kind of break our concept of slope since they have an undefined slope. Okay, last two things here, parallel postulate, perpendicular postulate. So if we look back to the first slide with the warm-up, notice I put the line containing, right? So if we have a certain line parallel or perpendicular to another line that goes through a given point, there is exactly one line that fits that criteria. So kind of like how 2 points uniquely define a line, a slope and a point also uniquely define a line. And that makes sense from our slope-intercept form. We know that we can write y equals mx plus b given these two pieces of information. That uniquely defines that line. So these two postulates are basically just covering that idea. The parallel postulate says in a plane, so we definitely need to be in the same plane, parallel to a given line, and passing through a given point, there is exactly one line. And that is not the exact wording. If you want to get the textbook definition, feel free to look up the definition in the textbook. But I think that gets the idea across that if we have a slope, which we get from parallel or perpendicular, and we have a point that we're passing through, I guess technically the point has to not be on that line, given a point not on that line. There's only going to be one line that we can draw. This is exactly the same as the perpendicular postulate. The only change would be that we change the word parallel to perpendicular. And again, this isn't the formal textbook definition, but to me I think it gets across the key points that we're dealing with two distinct lines. We have a slope and we have a point, and there's exactly one line that goes through those. Very similar to our postulate where it said through any two distinct points, there's exactly one line. All right, so that's review of notes and a couple new ideas that hopefully weren't too new. This is the example work that's on Canvas, so I'll go through it in case you need help remembering how to do this. But if not, you can just go through it yourself from the document on Canvas, and you don't have to worry about watching me do it. But it says find the slope of each line. So first one, we have slope-intercept, so m1 equals 2. This one, slope-intercept, m2 equals -2. This one, also slope-intercept, m3 equals -0.5. And the last one is a little different. That's in standard form, so we can't just read it directly from here. We can either rearrange and move stuff around and divide, or we can use the relationship that -a/b is the slope in standard form. So that would be, well, they have a and b backwards, so that would be -4 over -2, so my slope would be 2. Okay, so parallel, m1 is parallel to m4, or line 1 is parallel to line 4. And then we have this -1/2, that would be perpendicular to +2, so these are both perpendicular to number 4. So that should cover those. Line K passes through 0, 3. They give me a graph, so I'm going to draw that, and 5, 2. 1, 2, 3, 4, 5, 2. Graph the line perpendicular that passes through the point 1, 2. So I'm going to have a second line going through 1, 2 that has a perpendicular slope. So important, I need to find out my slope here. I go down 1 and 1, 2, 3, 4, 5 right. So my slope was -1/5. I could have gotten that by calculating from this as well. Do 2 minus 3 is the -1, 5 minus 0 is the 5. So I don't need a graph to calculate it, but they gave me one, so I'm going to count. All right, so that means my new slope is the opposite reciprocal, because I see my keyword perpendicular, so my slope is 5. 1, 2, 3, 4, 5, and 1. 1, 2, 3, 4, 5, 1. So this line is going to go, and this will look terrible, I'm sure, something like that, except we draw with a straight edge, and we draw nice straight lines on paper. All right, and then if we drew the blue line, we could see those look pretty much perpendicular. All right, next examples. Given these points, write the equation of the line in point slope form. So these are very similar to what we did in the warm-up, but again, in case you need extra help, I'll go through them again. So given these points, we're going to calculate a slope as -5 minus 3 over -2 minus 0. That's -8 over -2. That gives us 4. So point slope form, we're going to use one of these 2 points. I'm going to use this one because I don't like using ones with 0 for point slope form because it doesn't look like point slope anymore. So we'll do y plus 5 equals 4 times x plus 2. If you wrote it the other way, it would be y minus 3 equals 4 just times x, because x minus 0, the 0 goes away. Write in slope-intercept form passing through this point parallel to this line. So our original slope is 3. So parallel, our new slope is also 3. We pass through this point, so we could solve for the y-intercept either from point slope form or by substitution. I'm going to do substitution to say 1 equals 3 times 4 plus b, subtract 12, b equals -11. So my equation, y equals 3x minus 11. And then if you ever want to check, you can plug back in your point and make sure it works. So if I plugged in 4, I'd get 12 minus 11, that's 1. All right, write the equation in standard form passing through this point, perpendicular to line K with this equation. So my slope here, I can see, since it's in slope-intercept, is 2. So my new slope is -1/2. And then I want to write in standard form. So I'm going to start off with point slope and convert it into standard. So we'll do y minus -2, so y plus 2 equals -1/2 times x minus -1, that's plus 1. To get rid of the 1/2, instead of distributing, since I'm going into standard form, I have to get rid of my fractions anyways. So I'm just going to multiply everything by -2. That will give me -2y minus 4 equals, and then over here I just canceled out my multiplier. So I just have x plus 1. So then to rearrange, I'll bring the y's over here and the 1 over there and get x plus 2y equals negative 5. And again, if I want to check that that works, I can plug this back in. If I put negative 1 minus 4, because negative 2 times 2, I get negative 5. So that checks out. So that's how we do those. And then we have one more set of examples. We've got graphing 4x plus 5y equals 20. So we had a shortcut to find intercepts from standard form. To find the y-intercept, I basically ignore the x, cover it up, and say 5y equals 20, so my y-intercept is 4. Then likewise, I do the same to find the x-intercept. I cover up the y's. 4x equals 20, well, my x-intercept is 5. 1, 2, 3, 4, 5. So then that's my line. It just says find the x and y intercept. If I wanted to draw the line, I would connect those and make my line. And then last thing says, are the following equations in standard form? If not, write them in standard form. 8y minus 3x equals 6. Well, we have the x and y together, but the x's aren't in front, so that would be negative 3x plus 8y equals 6. Now, all three, a, b, and c, are integers. That's good, but a is negative, which we can't have. So we'll do one more step to switch the signs and say 3x minus 8y equals negative 6, and that would be our answer for the first. The second one says y equals negative 5. That is in standard form, because it looks like slope-intercept, but it's also standard because when there's no x's, it doesn't matter which side the x's are on. So we have basically 0x plus 1y equals negative 5. But we don't write 0x and we don't write 1y, so this is standard form. And then the last one, x and y are together. X is in front, there's no negative, but there's a fraction. So to get rid of it, we'll multiply everything in every term by 2 and get x plus 6y equals 12. And remember, they don't give us an example here, but we also can't have a GCF in our final answer. So if I had 3x plus 6y equals 18, I need to divide everything by 3 to get x plus 2y equals 6. That would be standard form of what we started with here. All right, so that's our notes. The rest of the time in class this day, we're going to be doing challenge problems for our race tomorrow, which is Wednesday. So there's a Canvas assignment to submit these problems. If you have something difficult, you can either use a problem based on what we did today with slopes and equations of lines and parallel and perpendicular, or you can do something based on angle measurement calculations like what we did with the transversals and angles. So be sure to submit one of those before 6 p.m. Tuesday so that I can compile those and we can do them on Wednesday in class.